So today we study the cross product. The definition is this. If vector A has the components A1, A2, A3, B has the component B1, B2, B3, the cross product of vector A and vector B will be given by this. And the notation is A cross B like this. It will be like this. Looks complicated. It's hard to memorize. But don't worry, we'll have some trick to memorize it. Okay? So note the cross product of A and B here will be a vector. It's very important. Therefore, sometimes we call it vector product. Okay? So if you don't know, let us memorize it. The determinant of order 2 is given by this formula, the notation. Suppose A, B, C, D are the numbers. The determinant of order 2 of these numbers will be the sign like this. It will be A times D. You can memorize it this way. Subtract C times B. That's you. Okay. For example, what is the determinant of 2, 3, 4, 5? Let's do it slowly, okay? 2 times 5 here. And subtract. Yes, 4 times 3 or 3 times 4, the same thing. It will be 10 minus 12, and it is negative 2. Very good. It's easy to remember, right? Or how about 2, 1, negative 3, 4? What is the determinant of these numbers? Yes, it is 2 times 4 minus. Very good. Be careful. The negative sign here is very tricky. So negative of negative here give us a plus, right? It would be 8 plus 3, and it is 11, right? So be careful. And another rule, the determinant of order 3, in notation, we write it this way. If A1, A2, A3, B1, B2, B3, C1, C2, C3, then the determinant of order 3 will be A1. Remember, look at this. A1, imagine in your head, you cross the column and the row. What is left? Will left, this guy will be left here, right? It leaves us the determinant of B2, B3, C2, and C3. Okay? Now, the second terms, imagine. We are going to the next element, A2 here. Imagine that you cross the row that contains A2 and cross the column contain A2 here. What is left? It leaves us B2, B1, B3, C1, C3, right? But remember, right here, the sign is negative sign. Be careful. Okay? And the next element, A3, imagine if we take A3 here, we cross the row containing A3 and the column containing A3. it reverses the determinant of B1, B2, C1, C2, right? Therefore, the determinant of the order 3 of this number will be given by this guy. Just memorize this rule. Let us practice this one. Okay? For example, if we are computing the determinant of 1, 2, -1, 3, 0, 1, -5, 4, 2. Okay? According to the previous rule, let us expand this determinant by looking at the first number here, right? 1. It will multiply with the determinant of order 2 of what? What is it? What is left? Imagine in your head you cross the column, cross the row. Give us
0, 1, 4, and 2.
very good. Who was that on Zoom?
Carrington.
Thank you. So the second term is the second element in this row, which is 2 times the determinant of order 2 here, right? Now, if we move to the next column here, we cross the column and the row. What is left here? 3, 1, -5, 2. Thank you. Camden. And the last one, the last element, it will be -1 here. Okay, -1 times the determinant of order 2 of what? Very good, thank you. 3, 0, -5, 4. Now it becomes easier, right? Let us compute it. 1 here, write it down. Multiply with the whole things here. What is it? 0 times 2 minus? Yes, 1 times 4. The second terms, minus 2 times? Yes. Yes. Let me write it down. We need more rooms here. Okay. -1 times -5. So be careful with the parentheses and bracket here. Okay, it's very, and plus a negative things here. It is the same as -1 times, what is it? Okay, now I want to remind you about this. Does it make sense if I write it this way? -2. Where do you mean, Aluk? Oh, -2 here, just a rule. Because remember, it's tricky right here, the negative sign. Okay, just memorize it. It's different from the other two. Okay, just memorize it, the rule. You will study it in later in linear algebra stuff. Okay, but now for now, just memorize it. And remember here, when you write mathematics, this is a multiplication of 0 and -5, if you write it here dot negative, it may confuse the reader. They may not know that if it is 0 subtract 5 or 0 multiply something, or is it a mistake. So it's very important to write it, the parentheses here, to make it clear that, okay, this is a product of 0 and -5, so that you won't get any mistake, okay? Be careful with this. Now let us compute it. It becomes easy. 1 times this is -4, right? It becomes -4. The second terms here, it is -2 times 6 plus 5, it is 11, yes. Minus 1 times 12, very good. So in the end, it would be -4 minus 22 minus 12, right? Very good, Zachary. -38. Thank you. So is it clear? Nothing difficult, just follow the rule, that's it. And I have one question for all of you. What is the result of 1 plus 1 times 2? Who was that? Very good. Thank you, Logan. 1 plus 1 times 2. Be careful. If we read it that way, remember we should do multiplication first and then addition later, which is the same as 1 plus 2, and it is 3. Thank you, Alok. But it will be different if you write it 1 plus 1 and then multiply 3 here. What do we have in this computation? Yes, 2 times 2, it is 4. So be careful with the parentheses to avoid mistake, because I saw in the previous test, some of you write it x squared plus 8 times e to the 2x, for example. If you write this way, we understand that we should do the multiplication first and then addition later, which is completely different from doing this guy, right? If we write it this way, we should do the distribution, right? So be careful with this. Don't get this mistake. It's very important. Okay, we will go very slow. Let us continue. Okay, now from this, imagine that if the vector A, vector B, and vector C, we can decompose it as the sum of A1i, A2j, and A3k, and similarly, B is B1i, B2j, and B3k here. You can imagine this way. You treat I, j, and k as numbers, okay? Then the order determinant of the order 3 here, when you write it down, it would be this guy. It's easier to memorize this cross product rule. Okay? Look at this. The determinant here, this guy will give us a scalar, right? Scalar times I minus another scalar times j plus another scalar times k. So the result will be a vector, right? Makes sense. So that is the key difference between dot product and cross product. I found a very interesting videos, and I sent to the whole class about dot product and cross product. If you have time, please watch it. It's very good. Here, if we're given vector A and B like this, what is the cross product of A cross B? Now, if A is this guy, B is 2, 7, negative 5. What is A cross B? So it's easy, right? Just follow the definition, the order rules here. If we write it this way, it will be vector I, vector J, vector K like this, right? And remember, the orders is very important. A cross B, it means A should be at the second row, which is 1, 3, 4, and B is 2, 7, negative 5. If you write it in different orders, you may get a different result. We'll see it later. Now, the rule tells us that it will be, let us consider the first component here, right? I, then expand it. It will be vector I, right, times the determinant of, what is it? Thank you, Walid. Perfect. And subtract vector J times the determinant of, very good. And the last one will be plus K times yes, 2, 7, very good. Let us compute it. Here, the number we can write in front of I is, okay, it's fine. So let us write it this way, I. The number here, it will be 3 times negative 5, right? Subtract what? Yes, 7 times 4. Subtract, what is it here? Very good. And the last one? Very good. Thank you. So okay, let us continue. The first one will be negative 15, negative 28, right? Very good. And the next one, it will be negative 5, negative 8. It will negative 13. In front of that is a negative sign. It will be very good. And the last one, yeah, 1K or letters, right? Simply K here, right? Or IJK here, we can write it in vector notation. It will be negative 43, 13, 1, right? We can write it this way. They're the same. Very good. And let us compute, this is the vector A cross B, right? And is at the beginning, let us compute. And now let us define this one as the vector C. You agree? Just define. C is A cross B. If C is A cross B, now let us compute C dot A. what do we have? A is 1, 3, 4. Okay, dot product of these two. And what is it? What do we have? And finally, it will be what is it? Yeah, 0. What does it mean if C times A dot C dot A is 0? Yeah, it is perpendicular. In notation, we can write it this way. C is perpendicular to A because the dot product is 0. Thank you, Alok, and everyone. Very good. So let us do the similar things. How about we find the result of C dot B? What is it? Right? And do a similar things. You see that this dot product is also 0. Okay? Then we have a theorem that the vector A cross B is orthogonal to both A and B. Okay? Since the cross product is a vector, so the direction of that vector is very important. How can we find the direction of that? And it also follows the right-hand rule. If vector A is your index finger, right? Vector B is your middle fingers. Then the vector cross product of A cross B will be pointing up, follow the direction of your thumb. Right? You see? A cross B give us this direction, right? And this cross product perpendicular to both A and B. Very important. How about B cross A? Yes, that's correct, Alok. The cross product makes a vector orthogonal to both A and B here. Okay, it's very helpful in the future. How about if we do the other way around? If we take the cross product of B cross A, right? B cross A, imagine in your head. If B is your index finger, right? A is your middle finger. Then the thumb will be pointing down, right? See it? It means that B cross A will be pointing in the opposite direction to A cross B. Can you imagine it in your head? Then we see that they're pointing into the different direction, opposite direction. We have these properties as well. B times A would be -1 of A cross B here. Okay? It's not very difficult. Just memorize it. Let us move on. Here, a theorem that sometimes the magnitude of the vector A cross B is the magnitude of A times the magnitude of b and sine of the theta, where theta is the angle between vector A and vector B. Okay? If vector A is parallel to the vector B, then it means that the angle theta between them will be 0, right? The angle theta is 0, imply that sine of this will be sine of 0, no matter how big A is and B is. If they're parallel, the cross product will be 0, right? Very interesting properties. And look at this. If this is the vector A, this is the vector B, and theta is the angle between A and B here, the altitude of this triangle will be the point, this pointing to this direction. Then the trigonometry relation tells us that how long is this altitude? It will be magnitude of vector B times sine of theta here, right? That is the altitude here. Do you agree? So the area of a triangle, it will be 1/2 of the altitude h times the base. The base in this case is the vector A, right? Now let us avoid using the same notation, it's fine. Imagine, okay? Which means the area of this triangle, it will be this big, the altitude of this, which is 1/2 of absolute value of vector B times sine theta. And the altitude of this has the magnitude of the vector A here, right? Or let us rearrange it. It will be 1/2 of vector A, vector B, sine of theta here. Okay? If we write it this way, then from the theorem here, right? It means that the area here will be 1/2 of the magnitude of the cross product of vector A and vector B. Okay? Or in other words, the area of parallel of this guy, parallelogram, will be twice double of the area of this triangle, right? Or in other words, the cross product of A and B here will be equal to the area of parallelogram here, determined by the vector A and vector B. Okay. This is a geometric interpretation of this cross product. Are we good? People on Zoom, can you follow it? Thank you. Very good. So now, let us do this example. Before doing that example, let us go quickly about this. So the cross product, apply the right-hand rule. IJK, the cross product of I times K will be I times J will be K, and J times K will be I, and K times I here will be J cross. But J cross I will be negative of K, K cross J will be negative I, and I cross K will be negative of J. observe that this cross product here, okay, they're different. I cross j is not equal to j cross I. Okay, and therefore the orders is very important. A cross B and cross C is different from A cross B cross C here. Very important. Okay. Okay. Do this in order. So now let us do this example. I think you can do it at home. Next time we'll continue. Let us go quickly about this. Okay. These are some properties of cross product. A cross B will be negative of B cross A. Scalar C here times A cross B would be, we can take that scalar out or multiply that scalar with B first. Okay. And distribution rule still apply here. A cross B plus C will be A cross B plus A cross C. Okay. A dot B cross C equal to A cross B dot C. And this one is called the triple product. This is also the determinant of order 3 of vector A, B, and C. Okay. Look at this. Let us compute B cross C here. B here, C is here, right? The vector B cross C will be this vector. It's perpendicular to both. So you see that they draw a straight line up here, right? B cross C is perpendicular to B, C here. And B cross C gives us the area of this guy, right? Okay. I think please go home and read ahead this triple product, and next time we'll continue later. Okay. I'll see you tomorrow. You have a good one.